Half-life. This video will explain what half-life is and how to work it out. The periodic table shows all the elements we've discovered so far. Most elements are stable, however, some are not. Elements are made out of atoms. At the centre of each atom is a nucleus, made from protons and neutrons. The nucleus of most atoms are stable. However, some are unstable, like uranium and plutonium. We call them radioactive isotopes, and they emit radiation from their nucleus to try to become a more stable atom. This process of emitting radiation is called radioactive decay, and you can see from this example that the unstable parent atom turns into a more stable daughter atom after emitting radiation. Radioactive decay is a random process, so we cannot predict when an unstable nucleus will decay. However, if we have a very large number of nuclei, we can predict an average time for half of the sample to decay. We call this time the half-life. The half-life of a radioactive isotope can be described in two ways. It's the time it takes for the number of undecayed nuclei in a sample to half, or it's the time it takes for the activity to half. Activity is measured in becquerels. We measure the activity of a radioactive source with a Geiger-Müller tube connected to a counter, often called a Geiger counter. Every time radiation goes into the Geiger-Müller tube, it clicks. However many clicks there are per second is the activity. We can use a graph to show the activity of a radioactive source. The activity always decreases over time. You get the same activity decrease if you drop Mentos into a fizzy drink.
What to do here, huh?
At first you get a lot of bubbles, but as time goes by there's less bubbles. The shape of the graph is the same as the activity graph for the radioactive isotope. Let's take a closer look at the activity graph for the radioactive isotope. We can see at time 0 that the activity is 160 becquerels. The half-life is the time it takes for the activity to half. Half of 160 becquerels is 80 becquerels. We can see from the graph that it takes 20 minutes for the activity to fall to 80 becquerels. It's important to notice that in another 20 minutes, the activity halves again from 80 becquerels to 40 becquerels, proving the half-life for a particular radioactive isotope is always the same length. Remember, the half-life can also be explained in terms of how many undecayed radioactive nuclei there are remaining. So if we plot a graph of undecayed radioactive nuclei against time, we get the exact same shape. We say the decrease is a negative exponential. It drops very fast at first, then very slowly towards the end. I've simplified the numbers involved to make it easy to draw. In real life, there'd be millions of atoms involved, not just 16. Do you notice how the number of undecayed radioactive nuclei remaining falls by half after 20 minutes? That shows us that the half-life is 20 minutes. It falls by half again after another 20 minutes to leave only a quarter of undecayed nuclei remaining. Some radioactive isotopes are very reactive, and so the half-life is short. The activity drops very quickly, as the graph on the left shows. Some radioactive isotopes are not very reactive and have a long half-life. Their activity drops very slowly, as the graph on the right shows. Let me show you some typical half-life questions. Question 1. The activity of a radioactive isotope is 1280 becquerels. 120 minutes later, the activity has dropped to 80 becquerels. Determine the half-life. Pause the video and give it a try. And here's the answer. I like to set these kind of questions out like this. Start with 1280 becquerels and keep halving it until you get down to 80 becquerels. You have to halve it 4 times, so that means there are 4 half-lives in 120 minutes. Divide 120 minutes by 4, and that determines the length of one half-life, which is 30 minutes in this example. Question 2, Part A. A radioactive isotope contains 4,000 undecayed radioactive nuclei. The half-life of the isotope is 2 hours. How long will it take the sample to drop to 500 undecayed radioactive nuclei? Pause the video and give it a try. And here's the answer. Start with 4,000 undecayed radioactive nuclei and keep halving until you get to 500. You have to halve it 3 times, so that means 3 half-lives have passed. Each half-life is 2 hours, so that means a total of 6 hours have passed. Question 2, Part B. What is the fraction of undecayed radioactive nuclei remaining after 3 half-lives? Pause the video and give it a try. And here's the answer. After 1 half-life, there's half left. After 2 half-lives, there's a quarter left, which is half of a half. And after 3 half-lives, there's an eighth left, which is half of a half of a half. I'll stop there, because hopefully you can see the pattern by now. It just keeps halving with every extra half-life. Hit the like button if you found the video useful, and subscribe to my channel if you want to see more content like this. Put a comment down below if you like the new animation style, and apart from that, work hard, be nice, and bye for now.